I don't mean to worry you, but I've had yet another revelation playing Resident Evil. No, I've shelved that concept. I still believe if we could move iron sulfide synthesis from scalyfoot gastropods to an anthropogenic fungus, we could structurally reinforce the human body at the cellular level, but we would be so heavy. Not to mention the overheating. No, it's just a pipe dream for the time being. No, I was replaying 2. The original 2. No, I don't want to turn this into that kind of conversation. I like both versions. Stop distracting me. We're going to have this conversation. You and I both know it. It's Plant 43, the big walking flowers. I was thinking about their biology, you know? Like, how they function and stuff. It's not that far removed from a spider, really. Well, that's just it. Once you start extrapolating the traits of spiders to actual, real plants, it starts to make more and more sense. Let's start with Plant 43. It's a video game entity, so its behavior is a lot simpler in scope than an actual plant. It has some traits that, at first glance, appear to be unplanty. Yes, I spent my weekend running over Plant 43's behavioral ecology and comparing it to real-world plants and spiders. What, does that shock you? Didn't think so. Okay, let's get the immediately obvious out of the way. T-virus-derived plant BOWs and happy accidents all move via hydraulic pressure. It's about the only practical way to justify any plant tissue moving at all, as plant biology is so wildly different to animal biology. We all know spiders use hydraulic pressure to operate their legs, and some plants can engage in limited movement via the same method. I mean, it's not cut and dry. I think predatory plants use stored elastic force, but that one plant... Which one was that? Right, mimosa, that one. That's thought to be hydraulic, right? Yeah, I thought so. No, it's nothing. I mean, I just forget how difficult proper names are until I talk to a non-entomologist. Anyway, so that's the immediate obvious connection. Hydraulic pressure as a key component of movement. Notably, Plant 43 is still very slow. I mean, in-game, they're a bit of a joke with how slow they move. I know spiders are generally fast-moving, but it's the relative movement I'm talking about. It's more the sessile lifestyle that got me thinking about the connection. I mean, most spiders are quite sessile, even though they have a complex locomotion system. An Ocantuaria can live in the same tunnel for like 20 years and never leave it. Even short-lived araneomorphs typically stick to one spot unless forced to move. Of course, plants are famous for their sessile nature, but then you get dispersal events. Yeah, wind dispersal. Both spiders and a variety of plants engage in long-distance dispersal via aerial planktonic transport, typically early into the life cycle. I mean, it's still a little different. Spiders rely on electromagnetic polarity for vertical lift, while plants are almost strictly gliding on wind currents. Unless someone finds out that they're also electromagnets, I guess. Yes, I'm aware that Plant 43 is, in fact, not sessile. Humorously, the remake's IVs are more traditionally sessile. They're parasitoids and clearly moving inside their hosts, but the actual locomotion is up to the host body. Now I'm distracting me. Focus. It's not just the hydraulics. Plant 43 specimens also spit acid. Well, it's described tacitly as acid. The actual word used is mucus, but it hurts, right? It does a little sizzle, too. Yeah, it's totally acid. Sorry, no, I think I know where I was going with that. So, spiders engage in external digestion, which is what I believe is happening here. The plant lobs acid at you. I have to make a jump in logic here and attribute function to the behavior. Presumably the plant is attempting to digest you externally. I mean, some carnivorous plants secrete digestive enzymes. I know. Digestive enzymes and stomach acid are not the same thing. Look, you have to truncate and make analogies that are not strictly accurate in order to help people understand a concept before you hit them with the raw complexity of reality. For the record, spiders use digestive enzymes, not hydrochloric acid, when digesting prey. In fairness, digestive enzymes are typically slow-acting. If I was an evil virologist and pharmaceutical expert, I'd design my slow-moving plant monster to make use of a high-powered acid rather than simple digestive enzymes. Bonus points, the wildly different base structure of plant tissues would render them more resistant to the acid itself. They'd be the perfect bioorganic acid turrets. Well, yeah, once we move the observations back, the real world... Look, I'm using Plant 43 as a model organism, then applying wider observational research to real plants to make my argument here. Damn right I did. So like I said, spiders, external digestion. They trap and wrap, spit digestive enzymes onto the prey to break them down externally, then slurp up the nutrient slurry. Pretty much because their actual mouth is tiny and can only really accept fluids. Plants are not that different, at least regarding nutrient uptake. I mean, there's the whole photosynthesis thing, but not all plants are photosynthetic. They do collect soil-bound nutrients, however, using their roots. More specifically, the vast majority of root-bearing plants have a symbiotic relationship with a fungal ally that does the digestion for them. Mycorrhizal thingy, you know? Yeah, that's the one, mycorrhizal hyphae. Fungal hyphae intake nutrients via external digestion on behalf of the plant, which is like external digestion squared. Well, I was getting to that. So heterotrophic plants that lack chloroplasts, and even hemiparasitic plants like mistletoe, they're largely epiphytic. I mean, not the saprophytes, they're usually parasitizing fungi. Now, spiders are also largely epiphytic. Not 100%, obviously. In fact, that could be an important part of the puzzle. Oh, please, let's not get into defining epiphyte again. It's a riddle for the ages, and we clearly aren't going to come to a common consensus on it. So spider diversity is directly associated with local vegetation structural complexity. It's a very well-known relationship with extensive literature surrounding it. With spiders being largely sessile as it is, and the majority of spiders being heavily associated with vegetation, you can start to see how through shared ecology and even limited morphological similarities, spiders are clearly plants. No, this isn't just because population modeling for spider ecology works better with statistical models designed for plants over models designed for animals. But I put that forward as further evidence. I think it all ties together rather nicely. The reality is that epiphytic diversity increases with vegetation structural diversity, much like spider diversity in abundance. More plants equals further, additional more plants, even more so if you include spiders within that grouping. Oh, right, Plant 43. I mean, there are other tenuous links. Plant 43 has the flowers branching from the primary stem on tendrils that resemble arms. Male spiders are similar. They have pedipalpal bulbs that are functionally reproductive organs for transmission of gametes. I know, I was getting to that. So I did say the connection was tenuous. Plant 43 are hermaphrodites, as are like 95% of plants. I mean, maybe that's not the exact wording. Most plants have both male and female reproductive capabilities, except in New Zealand where like 15% of plant species are dioicous. Naturally, everything has to be different here. Yes. Shut up, it was totally relevant. Where was I? Alright, so I wanted to draw connections between Plant 43's sexual morphology with spiders. I went down a rabbit hole regarding hermaphroditism in spiders. I mean, they have the typical gynandromorphism, but that's like super rare in nature. I thought I had a lead with a particular lycosid, Notocosa bellicosa, but a colleague emailed me a few weeks ago regarding the apparent epigynum development on the males. I can't get into the details, it's all unpublished, but it looks like that might be a morphological red herring. Yeah, I know. Can't have it all. Still, it is a remarkable coincidence that Plant 43 would just happen to have so many connections to the arachnids. Better yet, the only real change between Plant 43 and real plants is that it's apparently cognizant. Adding simple movement and sentience apparently makes the real differences between plants and spiders negligible. I mean, outside of internal morphology. Once you get down to the cellular level, they're completely alien to each other. Then again, you can push further to the molecular level, and suddenly they're the same thing again. It's all just nucleotides and microfilaments at that point. Stop asking about my thesis. I hang out with you to get away from it. Nota cosa bellicosa. Nota cosa bellicosa. Sorry, Italy.